Hello and welcome. In today's video, we are going to be talking about sound and hearing. We will also be talking about frequency and amplitude, as well as how to protect our ears from loud environments.
Hearing sound is one of our five senses as humans. It allows us to communicate with one another, listen to our favorite music, and even be an alarm system to protect us from harm. For example, we recognize loud and aggressive sounds as dangerous, like explosions or earthquakes, and we have adapted to learn to be afraid of these loud and unpleasant noises. But how do we hear? Well, this answer is rooted back to what sound is. Sound travels in patterns called sound waves, which are vibrations that move through mediums like our air. These vibrations can be created in many ways. For instance, we are able to talk by having our vocal cords vibrate, and guitars make noise by their strings vibrating. These vibrating waves come in different forms, which make different sounds. These waves can travel through most solids, liquids, and gases, which is why we can hear through water walls and obviously air. In space, however, there is no medium like air for sound waves to travel through, which is why we cannot hear anything in space. Something called amplitude, or simply how tall the wave is, controls how loud the sound is. So if the wave is very tall or has a high amplitude, the sound we will hear will be very loud. Whereas if the wave is very short or has a low amplitude, the sound we will hear will be very quiet. Something called frequency, which is just how many waves occur in a certain period of time, controls how high-pitched or low-pitched the sound is. So, for instance, if the wave has a low frequency, meaning there aren't very many waves, then the sound we hear will be very low. If a wave has a high frequency, meaning there are lots of waves, then the sound we hear will be very high. These two aspects of sound, frequency and amplitude, can combine to make a high-pitched quiet sound, a low-pitched quiet sound, a high-pitched loud sound, and a low-pitched loud sound. The way we can hear is because inside of our inner ear, called the cochlea, we have tiny hairs called cilia. When sound waves travel into the ear, these tiny hairs vibrate and detect the pattern, frequency, and amplitude of the sound wave. The cilia then sends a message to the brain about the pattern of sound wave it detected, and our brain translates this message into understanding what we have heard. If we are exposed to very loud noises for a long period of time, our inner ear and cilia can become damaged and not be able to detect sound waves very well. This can lead to permanent hearing loss, so it's always important to protect our ears by earplugs when around loud noises and to not have our headphones too loud.
This experiment allows us to be able to visually understand how sound waves can move through the air and affect real-life objects. To do the experiment, you'll need the following materials: saran wrap, a large bowl, uncooked rice or sugar, and a speaker. First, take the saran wrap and place it tightly on top of the bowl and make sure it covers the whole surface. The important thing here is to make sure the saran wrap is tightly bound on the bowl and that there are no loose points. This will allow the sound waves to have the biggest impact on the sugar and rice. If you need to, you can tie an elastic around the bowl to make sure that it stays tight. Next, place the sugar or rice on top of the saran wrap and grab a speaker and play loud bass music beside it. The sugar or rice will move and bounce in correlation with the sound waves that are being produced.